so you guys can look at the screen all the time. Okay, so, well, I'm Leo Bastos, as you guys already know. I'm a postdoc here working with Wesley Porter out of Tifton. I have some experience in precision ag as far as using sensors for deriving side dress variable rate applications of nitrogen in corn and some other applications as well. And I just want to, so I'm joining here, George and Miguel, and teaching you guys this course. And I have some exciting things I want to be showing you today and throughout the next couple of weeks when I'll be here. So I'm excited to be here, and hopefully you guys can learn a lot from this experience. Okay, so a couple of things, you guys have probably been receiving the emails that I sent you with instructions both on the blog and on the GitHub website. So I'm going to keep using the blog mostly to provide you some instructions, but really all the materials that I'll be sharing with you, which are going to be a lot of materials coming up for the coming classes, is going to be through GitHub. So partially filled codes before the class. After the classes, I'm going to be posting the completely filled codes for you as well to have as a reference. Any data that we'll be using is all going to be coming from GitHub. So it's probably a good idea to bookmark both the blog and the GitHub page if you haven't yet, just so you have an easier access to those. Okay, so I just got some, and also if you downloaded this material from GitHub, I want to invite you to please unzip it if you have to, and then come on the 04 class code folder and double click that 0207 partial script. That should launch RStudio for you, and it should be seeing something like what I'm seeing here. So you can follow along, and there are some points that we're going to be coding, and I have some text and some code already in there, so you don't have to type everything, but you will need to type some with me as we go. So for today, I just want to, some of the learning objectives we have for today is become familiarized with R and RStudio, learn about some terminology and syntax that we use in R, understand different object types and why that's important. We're also going to be creating a simple data set and explore it a little bit, just so you guys have some idea of how to do that in R. And if we have time, we're going to explore a little bit RStudio projects, create a project and set it up that we're going to be using that workflow of things throughout. So if we have time, we're going to get to that. Okay, so let's get started here. So if I'm
just check to make sure everyone has what you have on your screen on their screen.
Perfect. Everybody in the room here has the script up like that? Not yet? Okay.
To everyone, what I suggest we do is whenever you are falling behind or there's something you don't understand, don't suffer in silence, just speak out, because the purpose here is to learn. And if it's moving too fast for you, just speak up so we can stop and backtrack and everybody is moving at the same pace, okay? I mean, this is being recorded, but the point is not for you to go back and learn it later, but to learn it as we're going through it. So don't be shy about, and don't, if you're on the Zoom, we're probably not watching the screen because we're all working on the code, so just speak up. Okay, so don't just send something in the chat.
That's perfect. Thank you, George, for saying that. And I was actually forgetting to mention that. So yeah, if I'm going too fast, let me know. If you get stuck, let me know. If you have a question and don't understand something, let me know. Because really, as George said, the goal here is for you guys to understand what we're doing and really learn to use this tool. So, okay, so were you able to pull that up, Victoria?
Yes.
Okay, perfect. Is everybody on Zoom good to go?
I learned something all on my own. I learned that I could open it up from within R by going to File, Open. Smart guy, aren't I?
Yeah, I mean, there's lots of things that can be learned on yourself here. Lots of options.
Yeah.
Okay, so I'm just gonna tell you a little bit about why am I bringing this software to you guys here? Why am I exposing you to R? So first off, it is a free software, right? So you don't have to pay for neither R or RStudio. it runs on multiple platforms. For me, that's a big thing because I use a Mac, and before using R, I was using like multiple softwares that were all Windows based. So like SAS and ArcGIS and Sigma Plot for plots, all these software that only work on Windows. And so for me, R is good because it works on Mac, but it's also great because it allows me to do all these things and much more that before I was using like multiple different softwares, and now I can do all in one, which is R. So I really love that part of it. Also, R has a huge online community and support. So I've been using R for over 5-6 years now, and still sometimes I don't know how to do something. I Google it, and normally just Google like, hey, how to do this in R, and somebody has probably asked a very similar question already. So it has a really good support that you find help and to learn things on your own, just on the internet. Also, it has continuous development, and this is kind of like that packages that you guys were installing. You can kind of think of them as like apps where you keep downloading things and adding functionality to R, and especially on the spatial data sciences, this is really growing a lot. So using imagery and using different databases that we can download, soils and weather, all through R is really powerful, and all these packages keep being developed. And also reproducible research. If you guys are in grad school now or are planning on grad school in the future, you're gonna hear this a lot. Reproducible research, what is this? It's basically when you, if I give you my data and my code, you should be able to run it and get to the same conclusion or to the same output that I did, right? So if you're publishing a paper that they ask for your data and your code and you provide it, anyone that downloads that should come up with the same results as you did on original paper. And this is big because on research, there has been multiple papers showing how there is a lack of reproducibility in research. And this is not just like from experiment to experiment, but also imagine if you do a lot of things in Excel, for example, how are you documenting that? Are you writing down each step of the way what you're doing? Probably not, right? Because who does that? And when you're using a programming language to do anything, you're documenting your actions through code, right? So your lines of code you're using, the functions you're using are there as a documentation of what you're doing. And this increases reproducibility to a huge extent and is becoming really important and demanded in the sciences. And R helps us with that. Okay, so I know that if you've never used R or RStudio before, you may be a little bit confused about, okay, do I need R? Isn't RStudio enough? What is that relationship there? So yeah, we need both of them. We need R for sure. And RStudio is just this, whatever we're seeing here is RStudio. So why do we use RStudio and not just R by itself? So if you think of it, R by itself is just the console, which is this window down here. If you were not seeing it, if it was like that, you can just click on it and it will pop up like that. So R is just the console. This is where really the magic happens. This is where R interprets our commands. And RStudio is everything else around it. So RStudio integrates various components of the analysis. For example, up here where we have the script, the script is where you write your commands or your comments. But then if you want them to actually be interpreted, we have to send them to the console, as you guys were doing when you install the packages. And normally, I suppose you could just type your code directly on the console. You could just type directly here. The problem is that that's not going to be saved. And if you want to share this with somebody else, even for yourself for future reference, it's not very wise to code directly on the console. It's good to have somewhere where you save it, and then when you want to run it, you just send it to the console by actually running the code. Just come back here. Also, RStudio brings in this color syntax, so you can perhaps notice how there's some different colors going on here. Depending on the thing that you choose, things will look a little bit different in different colors. That helps us to differentiate when you're calling a function, when you're using an object, and it's going to make sense as we go more into detail here. And also something very nice about RStudio that R by itself doesn't have is syntax suggestions. So you don't have to type this. I just want to show you. If I start typing here, install, you see how it already, so this suggestion here is RStudio at work. It has already seen that I'm typing something that has a function for it that we already use, the install packages. So it's giving me that suggestion. And if it hasn't appeared yet, you can just hit tab. So install, and it's showing me already. I can just hit enter then to accept it. And if I want suggestions that say inside functions, I can hit tab and it will give me a list of options available for me. So those suggestions are also RStudio at work, and it's really, really helpful. Okay, so let's take a look here at our RStudio so you get familiarized with what it is and what we have going on. So we already mentioned that the script is showing up here on the left, on the top left. The console is on the bottom left, like we saw here. Let me move myself out of there. So on the right here, we have the environment. So the environment is basically where objects are going to be saved, and you're going to understand what is an object in a moment here. But things that we start creating inside R are going to be starting appearing in our environment. And then this next one here on the right bottom, it has a couple of different tabs that we're going to be using. So it has a files tab that for now we can just ignore. We're going to be using this when we start using projects. And then it has a plot. So any plot that we created within our script is going to pop up here on this plots tab. And if we ask for help on any functions, it's going to appear on the help tab. So it's a very useful little square there in our environment for us to be aware. So RStudio has these 4 quadrants here with different things going on. And I just wanted you guys to be aware of that.
You know, is there a name for the top left quadrant that we're reading in?
So the top left, so this one here?
Yes.
This is basically where your code is going to be. So it could be, yeah, where your scripts are going to show up.
But there's not a name for it, for example, console, environment, whatever. It's just
No.
write our script. Okay.
Yeah, it's just where the script is.
Dr. Bastos, is
Yes.
script a good name for it? Script, we can call it script, right?
Yeah, so what we're working with right now is an R script. We're gonna be exposed to a different type of code extension later when we use Markdown. But for now, yeah, we can call, because it is .r, this is an R script. That would be the way that we refer to it. Okay, so let's get working here. So one very important thing in R that you're gonna use a lot and hear a lot about is an R object. So what is an object? Well, before we actually create our first object, I just want to show you something here. So let's say the simplest thing you can use R for is as a calculator, right? So let's say if I just type a number here, 43 divided by 13. You can do this on your side as well. So anytime that I'm programming here on the script, you're welcome to do that on your side as well. So, and all the mathematical notations like division, multiplication, square root, or anything like that, exponential, is the same as you would use in Excel. So it has that same syntax. So here I'm basically, if I want to divide 43 by 13, I just have my cursor right anywhere in this row here, and I click run. So what happens is when I click run, this mathematical function here, which is a very simple one, is sent to the console, and we can see right there. And then R interprets that and it spits out the result for us. So that numerical result is right there, and we can use, do any type of complicated math that is going to work the same way. Just move this here. Let me see. I have a cheat sheet here that usually I have on my second screen, so you guys don't see that. Okay. So now let's say that this number 3.307 something is a number that is important for me and I want to use again down in my analysis. And so with that, I want to save it to something that I can call later. Let's save it to A here. So we have A, and then to save it onto A, we have to use this notation here that is less than dash. So this is the get or assignment function or symbol that we use in R. So we can say R gets 43 divided by 13. And then if we run that, what we're going to notice is that it was sent to the console, but the console didn't print anything. However, I don't know if you noticed, but when we ran this piece of code here, this little A appeared in our environment, meaning that A was saved in the environment and it is available for us to use down the road on this analysis. So this is a very, very simple case of where we only saved a number and A here is an object. So anything that we're saving something to that other thing. So here on the left, we have A, then we get sign, and then something that we're saving into A. So A is an object. And if we now come below here and just print, just write A out and run just A like that, it sends to the console A, R interprets that A is an object that has been saved, and then it prints out whatever was inside A. In this case, it's just this simple number. Okay. So we're going to be using this get symbol here a lot when we're saving whatever it is on the right side onto something that we're naming on the left side. So that is what an object is.
So Leo, is there a
Dr.
library
Basker.
somewhere where we can look these things up?
Sorry, can you say that again, George?
Yes, is there a library built in where we can look these up? Because, you know, it's hard to remember just symbology like that if you're not a constant user.
Yeah, I mean, I don't know actually. I mean, not natively in R. You know, if you Google like what is an object or how to save a result to an object in R, I'm sure there's going to be something that pops up, but not natively.
It's on the right side in the top right. It says name A and then it says the value. Just right there. Yeah.
That's not what I was asking, Sarah. Thanks for pointing that out. I was asking, where would I know to use less than and dash to save the variable, you know, the value to the variable? That's what I was asking.
Okay.
Yeah. Oh, and also something that maybe you noticed, but I forgot to explicitly mention is in an R script, if you want to make a comment, meaning that you don't want R to try to interpret it, you just use a hashtag. So let's say if you wanted to make a comment on your side here, on your script saying, you know, to save something to an object, use less than, you know, you can use a hashtag and you can add a comment to your script that way.
Dr. Bastos, I have a question.
Yes.
So whenever, in R, whenever you assign that variable with the less than and then the dash, so you don't have to use print like in Python. Like you just use like the A, like whatever you assign, whatever the name of that variable is that you assign to, you can just type it in and you don't have to like use the print command.
That's right. Yeah. I mean,
Okay.
Yeah, I never use the print command. And that's a great point because there are some languages like Python where you really have to explicitly say print, right? So here would be, there is a function called print that we could say print A and run it. And that would give us the same output if we only run A by itself. So in R, it kind of understands that if you're asking for an object that has already been created, it's going to print it for you, because it kind of anticipates that that's what you want.
Great, thank you.
Yeah. Okay, so let's create a few different objects here. So let's see what I have. Okay, so what if I wanted to, instead of a single number, what if I wanted to save a few numbers for whatever reason, right? So let's do that here on B. So B and then the get sign. And let's say if I wanted to do like 10, 5, 2. If I run this, it's not going to work. It did not understand why am I using the commas there. So in R, every time you want to give more than one value and save that to an object, we have to use the C function, which is like this. And C stands for concatenate. So puts together multiple things and then assigns to an object. So if we run this now, we see that B appeared on our environment. And if we just type B and run, so we printed, we're going to print 10.5.2.
I understand what you're doing there, but what does it mean when B equals 10.5.2? What's the point of that?
I mean, this is just like an example, right? But it could be in some cases we're trying to, let's say, create a data frame. Perhaps we don't really do that manually most of the time, but if you wanted to do that manually and you wanted a certain column to have these three values, this is how you would give those three values to that column. Yeah. All right, so let's see what else I have here on my cheat sheet. Okay, so right now we only say, so A has one number, which is the result of this division. C has three numbers, but we can also save words or strings to an object. So here on this C object, let's just use the assign symbol, and let's use open and close quotation marks and just add the word workshop. And if we run this, we see again that C now is appearing on our environment here on the top right. And if we print C, now C is a word. So this is just to show you that and you're going to see multiple different things being saved to objects, but here we saved a single number, multiple numbers, and a string or a word. Okay, so up until now, we only have these simple things saved to objects, right? So what if we actually wanted a data frame? Because none of these are data frames, right? They're just like a single or maybe three values, but not organized in a data frame. So there is this function here called data frame. And I have already left it there for you, so you don't have to type anything yet. But what I'm saying here is I want to create in this data frame a column called number, and I want this column to have whatever B has. So this column is going to contain all those three numbers that B has. And then another column called ID, and I want this column to have whatever C has. So C has one word, workshop. So if we just run that, and then run D just to print it on the console. What happened here? So now, I mean, we can see that we have the two columns that we wanted. So number and ID are the column headings, and we have three rows. And that's because number had three entries, so 10.5.2. But then what happened with ID? So we only gave one string, one word to fill on this column here. So what R did is it basically recycled that one string to match the number of rows that number had. So that's why we see workshop 3 times here. So that is a behavior that R does a lot of times. And I just want to quickly show you another example. Let me just show you here another example of how R recycle things. So we know that B has 3 numbers, right? What if I wanted to divide B now by, so we divided A was 43 by 13. What if I wanted to divide all these 3 numbers by 13? I basically just do that. B divided by 13. And then it's going to recycle that 13 for each element of B, giving us the outputs. So you don't have to save this. It was not really planned. I just wanted to show you how R recycles things, names or numbers to make it match and to anticipate what you may want to do with that number.
You know, the 1, 2, 3 is just row numbering, right? It's not anything we've created. When down here on the console, when we got the results, the 1, 2, 3, that's just row numbering, right?
That's correct. Yeah, those are the row numbers. Yep.
Okay.
Professor, I had a question.
Yes.
Is it possible for a data frame to have different columns having different number of rows?
So the data frame itself will always have the same number of rows. What could happen is, let's say in one column you have NAs, for example. Like, let's say you have a total of 5 rows in that data frame. One column has all 5 rows completed, and the other one has 3 rows with values, but 2 NAs in the other 2 cells. That's what it would basically do. The data frame as a whole is still going to have the same max number of rows, but maybe one of the columns only has 3 values and the other 2 are filled with NAs. So that's kind of R handles that.
So why did this data frame function did not put NAs and just recycle the ID?
Which function did you ask?
The data frame, because when we put ID as our second column, it didn't put NAs in the other rows, but it just recycled it.
Yeah, so you're asking like why did it recycle workshop and then not didn't fill up with NAs? Yeah, I guess it's just the way that R behaves is like if you give it something, it will recycle it. But if you give it nothing, then it will put NAs. And we're going to see more how that works with some more examples that are going to come up. But yeah, if you really wanted to have NAs, you would have to program that. And we're going to see an example down here where that's the case. Okay, so I use R for like a whole bunch of things like cleaning data, plotting, statistical analysis, machine learning, graphs, maps. My blog I do in R. So R does a lot of different things. And like 99% of the time, I use data frames. I'm going to show you some other object types that R accommodates. You will probably not use them, but I still want to make you aware that they exist, so you don't, if you come across them, you don't think it's something very different. So one of them is a matrix. So let's create a matrix here on this object called E. So we use the get sign, and then there is a function. So if you can type with me here, there's a function called matrix. And let's say, so when we create a matrix, we have to give it the values that we want to have in this matrix. So I basically want to give it the values of B twice. So I want to pass the values of B 2 times for this matrix. To do that, we're going to again use the C function for concatenate, and then do B and B, and then get outside of that parentheses, add a comma. And if we hit tab, you're going to see that it's going to give us some options here of arguments that the function matrix has. I just want to come here and say ncol, which is number of columns, equals to 2. So if we run that, we see now that E popped up here on the right on our environment. And if we print E, we have a matrix. And you can see how it looks different than a data frame, right? The main difference is that we don't have, the columns don't have titles, they don't have headings. It's just the position of the column. And the rows, the row is not like a row number anymore, it's more like a matrix position, right? So this is basically how you would have a matrix in R. And again, I don't expect you to be using matrices, but I just wanted to see what one looks like and how you would build it in R. Okay, so let's move on to our next.
Can you clarify again for us exactly what the C parentheses does?
Yeah, so every time that we want to pass more than one value to anything in R, really, like let's say if we want to save multiple names or multiple numbers into an object, we would use the C function, which stands for concatenate. So you're concatenating things. As
you write that for us somewhere as text so we can get the word? I'm not fully understanding the word.
Yeah. Like that.
Okay.
Mm-hmm.
New word.
Yeah. Yeah, so basically you're just making a bundle of things and turning that into something else. That's basically what the C function does.
Thanks for the clarification. Everybody understand that? Okay.
Okay, so I want to show you one more object type here, which is called a list. So a list is a little bit different. As you start becoming more expert in R and start using it for more complex things, lists are going to come up more. I don't expect you to do anything in this course with lists, but in my case, I use data frames, and lists are what I use most of the time. So I just want to expose you to a list. So let's create a list here on this object called F. Let's use that get sign. And then the function that we use to create a list is called list. Pretty intuitive. Let me just check here my cheat sheet to make sure I'm following. Okay. So the main difference between a list and a data frame is that a list can contain multiple different objects. They do not have to match in number of components of each one of those objects, and they do not even have to have the same type. For example, what do I mean by that? Let's create the first element of this list and call it number. So if you can open and close quotation marks, have your cursor in between and just type number. And let's use the equal sign here and say A. So we're basically creating a component of this list that is named number, and we're assigning the object A, which has a number, to this component. I want you to add a comma after A, hit enter, and let's now, let's see what I decided to do here. Okay, so let's do numbers. Let's do the next component, open and close quotation marks, call it numbers, so plural, and say that equals to B. And add a comma, hit enter. And lastly, let's open and close quotation marks again. Let's call this data equals D. So D is our data frame object, right? So if you look at this, A was one number, B was three numbers. Data frame actually had B and C, which was workshop, right? If you were able to follow along with me and add the commas in the right places, had all the open and close quotation marks, everything was all right. And if you run this, you should not get any errors. So one of the places where you would get errors in R is if you have too many or too few commas, or maybe they're not in the right place, or you didn't close something like here, this parentheses is closing that first one. So those are just some tips that if you get errors, just look for those. So I created F, and now let me just print F so we see what is going on. I'm gonna bring this up. So look what happened. F now is using the $sign to tell me that it has different components. So the first component that we call number has a number. The second component has three numbers, and the third component is an entire data set in itself, right? So we see here that lists do not try to match, like if things don't have the same size, lists will not try to match that size as a data frame does. A list will have as many components as you want to give it, and they could be all different. Okay, so was everybody able to create the list? Okay. On Zoom, does anyone need help or? Okay, I'll take that as a no. So I want to introduce you to this function here called class. This is going to be a very, very important function because it will help you to understand how R is interpreting the type of an object. I know that's a mouthful. Let me just walk you through why that's important. So if we use this function class on F, so we're asking R, what is the class of F, right? So let's just run that and see what R tells us. It is saying that F is a list, which we kind of knew just from the name, right? And because I told you as well. However, F has components. right? So the components that we created here, A, B, and D. If we do class F and, well, let me type this myself so you can see. So class F, and then when I add a $, it already populates for me the components of F, so I can just choose one. So let's say if I do data and I run it. So data that is inside F is actually a data frame, even though F in itself, so the higher level F is a list. So this works when we want to know the class of either an entire object or perhaps pieces of that object. In this case here, the entire object is the list and data is a piece of it. But this function class also works for data frames. So let's say if we do here class D, so D is our data frame, it's gonna tell me it is a data frame. However, D has 2 columns, right? Again, the same way that the $ worked for F, that was a list, also works here for D, which is a data frame. So I use the $, I get the 2 columns that it has. Let's say I want to know how R is interpreting the column ID, which if I'm just going to print here D so you can see again, D is a data frame that has a number and an ID column. So if I ask R, what is the class, the type of the column ID inside the D data frame, is going to tell me it's a character because it has the word workshop. Does that make sense? So things have different classes, right? So you can have a number, you can have a string or a character, you can have an entire data frame, you can have a list, a matrix. All these things have different classes. And that is important because the class that something is will impact what you can do with it.
So quick question. The $, that is, you always have to put a specific after it, correct? Like what it's named from within the F or the D, whatever.
That's correct. Yeah,
Okay.
It has to be. So yeah, the $ helps you to go inside that higher level object and select one of its components, basically.
So like a subset. Okay, good
Mhm.
deal. Thank you.
Yeah. Okay, so we learned here about objects, object classes, and types, and some examples here. And I've been telling you about function. Oh, we use this function for this, that function for that. And oops, sorry. Let me go back here. So what makes something a function in R? So basically anything that has a name. For example, let's use here the function called mean. So there is a function called mean. And what makes it a function is first, somebody at some point wrote code and named whatever that code does as mean. And we know it is a function, like us users, not the programmers writing these functions, but us, the users, know it is a function because it has a name and it is followed by an opening and closing parentheses. This is what makes a function, right? So the mean function is pretty useful, and it does what you think it would do. Basically, gives you the mean of some numbers, right? So let's say here, if we just added our object B, which again is 3 numbers, inside of this function, and we ran it. Basically, mean sees that object B has 3 values and gives us the average of those 3 values. Pretty handy, right? Okay, let me just check my cheat sheet here. Oh, yeah. Okay, so let's another function that's going to be very useful is the help function. So every time you need some help, like you know what function you need, you just don't know what you should give it for that to work. We can use this function called help, and inside here is basically the name of the function that we need help with. So if we just run this help mean, we're going to see here something on the help tab popped up. That's basically the documentation of this function called mean. So it's telling, it gives us a description, it gives us some of the arguments that this function takes. So X is basically just, some numbers that you give it. Also has the arguments trim and NARM. So NARM stands for not a number remove. What does that mean? Let me show you something here. So let's create here an object called B2 that is going to be the same as B. So we use the concatenate function. And let me just print B so I remember what were the values in B. So 10, 5, 2. So let's do 10, 5, 2, but let's also add an NA. So not a number. So let's say if you had a study and you measure yield and a deer actually harvested your corn plots before you were able to do it, you lost your yield data. That plot is an NA. You don't have data for it. So let's just create this object here called B2 with an extra element that is NA on it. And let's just print it so we see what it is. So basically 10, 5, 2 and an A. So let me show you here. After we print it, I just want to call mean of B2. So remember that when we ask for the mean of B, we got the mean of those three numbers. Now on B2, we have those three numbers, but we have an NA as well. So if we ask for the mean of B2, oops, it returned NA. The reason for that is the mean, the minimum, maximum, median, standard deviation, all these basic statistics function in R assume that if in whatever you're asking for that to be computed, if that has an NA, by default is going to return you NA. It's not going to try to calculate that. So what happens then is that this mean function, as we're looking here on its documentation, has this argument here called NA remove, NARM, that by default is set to false. So it does not remove NAs before calculating things and actually gives you an NA back as a result. To change that behavior, we can just add a comma, call that argument here, so NA.remove, and say true. If we run this now, look at that. We get the mean of B2, which is the same as the mean of B. It's just that we had to explicitly change the behavior of the argument NA remove. So just taking a step back here, we have functions, and inside functions, there are arguments that are things that the function is either expecting you to give, or if you don't give it, it's going to use a default assumption. In this case here, NA remove default assumption was false, and it was giving us the result of this mean as NA because B2 had an NA. To change that, we explicitly called the name of this argument, which I learned there exists because I looked at the documentation that I was able to access using the help function, and I changed that default behavior. Does this make sense? Okay. All right, so we're approaching 10. I think today's class ends at 10, right?
Correct. Okay.
Okay, so let's do this. So let's stop here and we'll continue Wednesday from here on. And then, so I had an assignment here, but let's do this. Yeah, let's just skip this assignment for now. I'll give it on Wednesday for you guys. So yeah, Wednesday, we're gonna have a reading assignment of a paper. And then we'll just continue here. So we'll just starting a package and going through here to the end. And if I mean, we will for sure finish this script here on Wednesday. And after we finish this, we will start doing some data cleaning on some actual precision ag data. It's going to be a yield monitor data that we're going to start working with. So with that, I will upload by Tuesday night for sure, I will upload another script to GitHub, which is going to have the partially filled script for the yield editor, yield monitor data part, and also that data itself. So I will add a data set and also another script to GitHub. I will let you know once I do that, so you can download it. But we're going to also be using that Wednesday. All right. I just want to open the floor if anyone has any questions before we finish here. On Zoom, anyone has any questions?
Those of us who are new to R, we may feel a bit overwhelmed by all these new commands that we're learning, but Wednesday, I expect we'll start applying them, right? And then we'll have that homework assignment to reinforce what we've learned. So there's the recording. So how do we save what we've done? If we exit RStudio, is this stuff saved?
That's a great point. No, so I mean, it may prompt you to save it, but you can just go ahead and click on that. So on this save symbol here, on mine is not showing active. Maybe I have already saved. Yeah. So if you write anything, it will prompt you to save it. So just click there, and then it should be saved wherever that file is. So it may still be inside this folder here, the class code folder. So that's where it is saving to. Oops, let me go back. Yeah. All right. Anyone on Zoom has any questions? So in the meantime, let me know if you guys need anything, you have any questions, or if you're just trying to understand some concepts that we talked about today. I will be super glad to help you by email. And if you're in Athens, you can stop by my office and we can also go through that. And otherwise, thanks for joining the class, and we'll see you Wednesday.